So this is Vijayalakshmi, Assistant Professor from Mechanical Engineering Department, Thandai Periyar Government Institute of Technology, Vellore. So this is the part 2 of problems involving the cam profile. So today we will see how to draw the cam profile in the case of a mushroom follower. So it is required to set out the profile of a cam to give the following motion to the reciprocating follower with a flat mushroom contact face. The follower is to have a stroke of 20 mm during 120 degree of cam rotation, follower to dwell for 30 degree of cam rotation, follower to return to its initial position during 120 of cam rotation, and the follower to dwell for the remaining 90 of cam rotation. So the minimum radius of the cam is 25 mm. The outstroke and the return stroke of the follower is performed with simple harmonic motion. So first we will draw the displacement diagram. We will mark off angles 120 for outstroke, 30 for dwell, 120 for return stroke, and the remaining 90 for dwell. Next we will divide the outstroke angle into 6 equal parts with half of stroke as midpoint and half of stroke as radius, that is 10 mm. Draw a semicircle, divide the semicircle into 8 equal parts. Number them at A, B, C, D, E. So the line from A will meet the line from 1, that gives the point B. Line from B will meet the line from 2, C. Line from C will meet the line from 3, D. Line from D will meet the line from 4, it is given as capital E. Line from E will meet the line from 5, F, and the last one is G. Again till H you have the 12. So the same procedure is repeated for the return stroke. So after drawing the displacement diagram, we will now draw the cam profile. Since offset is not given, after drawing the base circle, we can fix the vertical diameter where it touches the base circle. That point is fixed as A. So join OA, then mark off the outstroke angle, that is 120 degree. Divide this segment into 6 equal parts and mark the points 1, 2, 3, 4, 5, 6. To all these points draw radial lines. Next, from the displacement diagram, you mark off distances 1b, 2c, 3d, 4e, 5f respectively from the displacement diagram from the base circle. So you will be getting the points B, C, D and F. So at this we are going to mark the flat faced follower. So let us assume that the contact surface is 20 mm. So with the B point as the midpoint, so you draw a line, tangential line equal to 20 mm. So in the side, this side you have 10 mm and the other side you have 10 mm. Similarly with the C as center, again you draw the mushroom, that is the flat faced mushroom follower. The total is 20 mm. So it should be tangential to the line. So through the line from 1, for that line the follower should be tangential. So the same is repeated through all the points. Through F we are again drawing the flat face mushroom follower tangential to the line. Through G we are drawing the flat face mushroom follower tangential to the line. Okay. So assuming this to be 20 mm, the point G will be at the center. So now to trace the cam profile, what we are going to do is we are going to draw a line such that it touches all the underside of the profile follower. So you draw a line touching the underside of the follower, or you can say it is tangential to the follower. So that will give the profile. Now if you are joining lines through all the points A, B, C, D, E, F, G, then that will give the pitch curve, which is the line traced by the tracing point. So the same is repeated for the written stroke also. So with this, we are all drawing tangential lines to the radial lines. We draw tangential lines with the point as center, and it is extending equally to both the sides. So this side 10 mm, this side 10 mm, like that. And then we are drawing the curve touching the underside of the mushroom follower. So that gives the cam profile. So let us consider one more type of follower, which is the roller follower. So draw the profile of the cam when the roller follower moves with cycloidal motion during outstroke and return stroke. Outstroke with maximum displacement of 31.4 mm during 180 of cam rotation. Return stroke for the next 150 of cam rotation. Dwell for the remaining 30 of cam rotation. So minimum radius of the cam is 15 mm and the roller diameter of the follower is 10 mm. Axis of the roller follower is offset by 10 mm towards the right from the axis of camshaft. So first we draw the displacement diagram. So since both the outstroke and the return stroke both have cycloidal motion, we are drawing the circle at the point of intersection of both these strokes. So now we are drawing a circle of diameter s by 2 pi, divide that into 6 equal parts, and then we are drawing horizontal lines to meet the vertical diameter of the circle. Next, we are joining A to the bottommost corner and the topmost corner of the outstroke. So that gives the diagonal. Now through all these points, we are drawing lines parallel to the AG. The same is repeated in the return stroke. Again we are joining the topmost to the bottommost and we are drawing lines parallel to the line GN. So these lines will intersect the corresponding lines at the various points as discussed earlier. So the line from 1 will intersect the line for vertical line from 1, and line from 2 will intersect the vertical line from 2, from 3 and from 4, from 5 and from 6. So all these points you mark and you join that using a smooth curve. So the same you can repeat it for the return stroke also. So once the displacement diagram is completed, then we can start to draw the cam profile. So since the follower is offset, we have to draw the offset circle too. So in the case of the roller follower, first we draw the base circle of the minimum radius, that is 15 mm. After drawing the base circle of 15 mm, then we draw the prime circle. So the prime radius of the prime circle is equal to radius of the base circle plus radius of the roller follower. So here, so the roller follower is diameter is 10 mm, minimum radius is 15 mm, so the prime circle radius is 20 mm. So now we are going to draw the This is the prime circle. Next, we will draw the offset circle, that is 10 mm. After drawing the offset circle, we will draw a line, vertical line tangential to the offset circle. It will meet the prime circle at the point A. Now join OA. With OA as reference, you mark the angle 180 degree. Now divide the prime circle into 6 equal parts. So 180 degree, you divide that into 6 equal parts such that you can mark the points on the prime circle. Through all these points, draw lines tangent to the offset circle. Then mark the displacements from the prime circle. 1B, 2C, 3D. You can mark the distance from the displacement diagram. Now, with A as center, you draw a circle whose diameter is equal to the roller follower diameter. Similarly, through all these points B, C, D, E, F, G, you draw circles representing the roller follower. So the same is repeated for the return stroke also. So to get the cam profile, you draw a curve tangentially to the roller circle such that it touches the base of all the roller circle. So this gives the profile of the cam. If you trace a curve passing through the center of all these rollers, so that will give the pitch circle. So this is how we draw the cam profile in the case of a roller follower. Thank you.